Good afternoon. Thank you for coming today. Today, three speakers prepared some topics to support developers. Junsik from Samsung and David from Unity and from me. We'll talk about several activities. First, I will introduce the GPUWatch tool briefly, and next, GameSDK and adaptive performance talk will be followed by next speaker. I am Hyun Lee from Samsung Mobile. I'm in charge of Android graphics and tool development. To achieve the best user experience in gaming, our Galaxy GameDev team has been doing many various activities since 2016. Typically, we are support technical, on-site and remote. And today, we'll talk about another type of support activities. The GPUWatch. These days, many people are enjoying games on their mobile device. And mobile game quality becomes reached to PC quality almost. But unlike the PC environment, we must be careful to use the restricted resource and power on mobile. And this means developers should pay attention to the performance. And we can use various monitoring tools, the performance monitoring tools for this purpose. For example, such as a Snapdragon Profiler and DS5 Streamline, GameBench, etc. These tools can give you many useful information. But sometimes, too many information makes it difficult to focus on the key factor. And it takes a lot of time and effort to get used to these tools. And plus, actually, these tools have several inconveniences. We need to install some packages on the PC, and we need to connect on the PC to use it. And it shows the display performance information on the connected piece, and sometimes not in real time, and does not support full capability without root permission on the device. We think these several inconveniences are preventing developers' access to the performance. So we made GPUWatch. GPUWatch is our brand name of performance monitoring tool. No installation or no PC connections are needed, and it shows the performance information on device directly in real time and support full capability without root permission for both Vulkan and OpenGLES. Let's take a look how GPUWatch is running. During some game is running, GPUWatch shows the performance information on device overlay in real time. There are several widgets to show performance information. Let's take a look at one by one. On left top corner, there is a FPS widget. Currently, it shows two data, the current FPS and average FPS. These two data are updated in real time in digit form, and it shows the recent trend in graph form together. And As you can see, two graphs are overlapped, so you can compare the current FPS to latest average FPS. Sometimes you may find that there happens some frame drop, like this. If this is not intended situation, developers may try to optimize this scene. Next, on top right corner, there is a CPU, GPU utilization widget. It shows CPU and current CPU, GPU uses as the same manner in digit form and graph form. With this information, for example, you may get some hint of CPU, GPU load balancing. For example, if CPU load is too high and GPU is low, developers can try to optimize to utilize GPU more instead of CPU. And next, on bottom of the screen, there is GPU profiling information. This information is frame unit. So for this, GPUWatch captures a specific scene. For basic information, by displaying the thumbnail of the captured frame and the frame number, we can know what exact frame was captured. And there is rendering time information as well. It tells that it took 18.1 milliseconds to render this scene. And there are 4 more graphs in below. The first green graph shows the render path information of the captured frame. Each block means the render path within the frame. And each render path shows 3 information. The first information is the index of the render path. As you can see this example, you can know that there are 5 render paths in this example, indexed from 0 to 4. And there are 2 more information, draw call count and payload count. With this information, you can know the status of each render path, how many draw call and how many payloads are there. And there are 3 more graphs. These 3 graphs are aligned in time together, so gives you the timeline information of the render path and GPU activities. The first graph shows how long each render path takes within the frame. And related to this, the next 2 graphs shows the GPU activity when rendering is performed. The vertex activity in blue color and orange fragment activity in orange color. Now, let me show you how to use GPUWatch. On Galaxy device of Android P OS version, you can find the GPUWatch menu in developer options. To activate the GPUWatch, first turn on the GPUWatch menu, and second, select one application or game to monitor the performance. And third, select one rendering API for Keun or OpenGL ES that is used by the selected application. That's all. It's very easy. Then run that application. Then you can see the GPUWatch shows the performance information on overlay in real time. You may wonder where GPUWatch can be used. Let me introduce today 2 typical use cases. First, you can use GPUWatch as your first monitoring tool for performance. Because GPUWatch can be used just with your device. You can activate it anytime whenever you want to monitor the performance. You can use the GPUWatch as your performance monitoring tool. And second, you can use GPUWatch as your performance comparison tool because GPUWatch shows the performance information on device directly in real time. You can compare among various devices with the same game contents, or you can compare the Vulkan and OpenGLS version of the same game contents. Especially when porting from one API to another, you can monitor the performance throughout your development process. Let me show you one simple practice using GPUWatch. This is our base project, rendering some complex scene. In Full HD resolution, GPUWatch shows you that the performance is too low, the 14 frames per second. It takes about 65 milliseconds to render one frame. And you can see that there are 14 render passes. And several render passes include some heavy payloads. So we made one optimization, the barrier optimization. After this, we got a little enhanced result about 20 or 21 frames per second. And you can notice that the render pass count was reduced from 14 to 2 render pass. But the performance is not good yet, so we made one more optimization, the multipass optimization. After this, we got a dramatically enhanced result, about 50 to 60 frames per second, and the render pass count was reduced one more time. Like this, GPUWatch can be used throughout your development process, anytime. Well, this is our roadmap. You can use this GPUWatch on Galaxy device of Android P OS version with these features that I explained today. And for next version, maybe Android Q, we are planning to prepare more features that can help developers. FPS stability and capturing some specific scene by user interaction or by issue detection, and memory profiling, more enhanced UX, and even dumping profiling data. Why GPUWatch? GPUWatch is not all-around player or one magic tool, but we aim to simple, easy, and intuitive way so that developers can access the performance whenever and wherever they want to watch it. You may know the highness law. Before one critical issue happens, there were 29 minor accidents and about 300 near misses. This means there were many chances to prevent the one critical accidents. By using GPUWatch throughout your development process from the beginning, we expect to reduce the critical effort for performance optimizing that can be possibly happens at the end of the development process. Our Galaxy GameDev team is doing various activities to support the developers. GPUWatch is one of them, supporting developer tool. And next, Junsik will talk about GameSDK, an activity to support developers in SDK form. Thank you.
Hello everyone, I'm Junsik and I'm working for Samsung Galaxy GameDev as DevTech engineer. Today, I will explain GameSDK, one of the things Galaxy GameDev support game developer. And next, David will announce on GameSDK's best practice, the adaptive performance. I briefly introduce myself. I worked as a graphics software engineer for 6 years. And now I'm working as a Galaxy GameDev team, support to game developer for best performance of mobile game. When Galaxy GameDev team did a lot of game collaboration through the GameDev, game developer has many problems and questions. So we have made Game SDK to solve and support this game developers' problem. Based on this experience has helped me to develop a Game SDK and Unity adaptive performance. Now let's talk about what you can do and how to solve the problem with Game SDK. Mobile games have some problems. First, mobile don't have an active cooling system. So there are limited conditions that can prevent heat itself. When running high-spec games in using high CPU and GPU frequency for performance, so then result temperature is rising. Temperature is exceeded certain level, then thermal throttling is happen for rising the temperature. For reduced temperature, governor significantly decrease CPU and GPU frequency, so then result performance drop sharply. As you can see the right graph, the before and after throttling. FPS is dropped sharply and it is not stable, and core frequency also decreased. Second, mobile had a limitation of battery. So when the same performance, it is better to use lower power. One way to reduce power is using lower CPU and GPU frequency. Actually, this problem comes from the limitation of mobile. But developers don't know that any information about thermal throttling and power control. That's real problem. Let's take a look at the thermal throttling. Imagine that you are in this situation. Your game target FPS is 60, so it works fine at the beginning. But FPS gradually decreases and shaking, the end of FPS is 40. If because high CPU and GPU frequency allowed at the beginning time, then thermal degrees goes up quickly, and then thermal throttling is happen. So average FPS is 50, but this critical heat-up problem hurts people's gameplay experience. So how to solve this problem? If you know that the thermal throttling timing, then you can do something on your game to avoid throttling. But you don't know that the thermal throttling timing, so you can not do anything. With the Game SDK, you can detect thermal throttling timing. On high temp warning API is the listener function. So with this API, you can detect thermal throttling timing through that warning level value. Warning level 0 is device temperature is low. And warning level 1, device temperature has risen a certain level. So that means thermal throttling will approach soon. So it is necessary to take action to reduce temperature. And warning level 2 means summer throttling is started. So using this API, you can predict summer throttling timing. So now you can do something on your game. And GameSDK provided various of temperature information. Each temperature information provided by abstraction level. Each temperature level range is 0 to 7. So with this API, you can know that the temperature of trend. Now, you can know the summer throttling timing and temperature of trend. So you predict summer throttling, and you should prevent summer throttling and performance degradation through that adjust target FPS and do something on your game. So please maintain your game's performance, and now your game don't hurt people's gameplay experience. What about power management? Do you have experienced this situation? Just a simple scene, but it looks like more CPU and GPU use and power. So when the same performance, it is better to use lower power. So we should reduce the unnecessary CPU and GPU frequency. But developer cannot control the CPU and GPU frequency. With the GameSDK, you can control the CPU and GPU max frequency. Send level with the Scene API allows that you can control CPU and GPU max frequency through that each level value. Level range is 0 to 3. So in this case, you set the CPU level 2 and GPU level 1. Then you can control the CPU and GPU max frequency and to reduce unnecessary power. What about Bottleneck Identify? Image that you are in this situation. Your game uses send level CPU and GPU by 1, and your game target FPS is 30. But your game running around 28 FPS. So in this case, you should increase CPU or GPU level. So if your game is CPU bottleneck, you increase CPU level, or GPU bottleneck, you increase GPU level. But you don't know that the bottleneck point. With GameSDK, you can identify the bottleneck point. You can get n frames GPU frame time with the get GPU frame time API. So you can identify, in this case you can identify the GPU bottleneck, so you increase the GPU level. We will look at the how to use GameSDK in several scenarios. So I last wrap up with the GameSDK goals. With the GameSDK, you can predict summer throttling timing. So you predict summer throttling and avoid performance degradation through that adjust game quality and maintain your game's performance. With the GameSDK, you can control the CPU and GPU max frequency. So please avoid unnecessary CPU and GPU power and extend your gameplay time. With the GameSDK, you can identify the bottleneck point, maximize performance and dynamic control power in your game. So to make it easier for developer to use GameSDK, we firstly collaborate with Unity. Since 2018, we are working with Unity for adaptive performance. So the best practice of GameSDK is adaptive performance. So that's all for me today. I will hand over David, Unity software engineer. he will be talking about that the Unity's adaptive performance.
Thank you, Junsik. So, welcome to this talk about Megacity and mobile and how we use the GameSDK to make our adaptive performance system and try to optimize Megacity. I'm David Berger, software developer at Unity Technologies, working on the mobile engine side of things. I have been there about 5 years, optimizing games from indie developer areas up to AAA productions, pretty much anything throughout the bank overall platforms we support. So those are games like Hearthstone or Ori and the Blind Forest. Pretty much anything mobile related really has the same kind of issues. And to get around those, we could collaborate with Samsung to work on the adaptive performance SDK. So for everyone who doesn't know what Unity is, we are basically a cross-platform game engine, 2D and 3D, also supporting over 27 platforms for games, AEC, movies, and auto industry. So it's quite versatile, and if you want to learn more about it, please come and visit our booth at 227. And we show a lot of great things. Also, we show adaptive performance and Megacity on mobile, running on the new flagship device S10 from Samsung. So, adaptive performance. As we heard, it's using, basically, is the best practice of using the Samsung GameSDK. Otherwise, it would not be possible for one of the biggest issues our mobile game developers face, which is predicting thermal throttling and actually do something preemptive against thermal throttling. So mainly because there is no way whatsoever to figure out when the device goes into throttling. And the Samsung GameSDK makes that possible for its users on Samsung devices. So we at Unity work together with Samsung to improve the SDK, to make it suitable for our users and integrate it properly into the Unity's adaptive performance system. What that actually means is that it's now possible for Unity's developers to easily obtain the device performance, status, and also the thermal trends. And you basically can now proactively adjust performance and quality settings over time and basically on the fly during runtime, which was a pretty hard thing to do before that. So that basically means knowing the thermal trends and the status of the device, that you can basically aim for maximum quality as well as for maximum performance, really depending on like whatever you try to achieve, what your game scenario is or your application scenario is. And overall, that means you can maintain smoother gameplay or smoother viewer experience. Which also means that you're gonna have a more stable frame rate over a longer time and have a way lower energy impact, which is great for the user experience, because who doesn't want to play longer Pokemon Go when they're outside, which is, a great use case. So to test adaptive performance, and the package we made is that we took Megacity and implemented it to see if adaptive performance can make an improvement to this project. When it runs specifically on the Samsung S10, which is like our reference device. So why Megacity? Megacity is a giant streaming world project which Unity unveiled last year, and we just released it for desktop this week. So if you want to check it out, please do so. It's a great demo project to test adaptive performance, because on mobile we basically have over 8 million, or we push over 8 million triangles to the GPU, we get more than 6 million singular entities in our scenes. We have more than 2,000 cars on the mobile version. We do have over 100,000 audio sources which needs to get mixed and presented. And we have basically everything dynamically streamed in and streamed out. And you might see that this could be problematic for a mobile device, especially to achieve 30 FPS stable over time, which is, to be fair, most of the games historically try to achieve 60 FPS, but mobile devices, you actually want to save performance. So most of our developers try to target at least 30 FPS rather than 60 FPS. And this is also one of the reasons why we choose 30 FPS to showcase that demo. And one of the things is, we look here at the frame rate of Megacity over a time span of 20 minutes. And you clearly can see this is without any optimization, just as it is running on the Samsung S10. So we start off pretty good. After loading, we are around 30 FPS. But then after thermal events are happening, the frame rate decreases and cannot really recover anymore. And then at some point, the device goes into throttling, which happens around 15 minutes. And at that point, the frame rate even drops further. And there is no way the device actually can recover without changing significant behavior in the game. So what did we do for Megacity when we implemented adaptive performance into the project? So basically, we start with low CPU and GPU levels in the menu, because in the menu there is not much going on. And moving over to the game scene, we increase the level for the CPU, mainly because it needs to cope with all the loading and like the initial loading and dynamic streaming, and we don't want to wait forever to happen. And during the game, we then increase the level for CPU and GPU depending on their bottleneck respectively. And that enables us to keep the energy consumption low. The other thing we do is not hitting the target frame rate. So when we are not hitting the target frame rate, we decrease the LOD bias, which is a substantial change in the visual representation of the game, but very necessary because it decreases the GFX load time. So this is one of the things we have to do to make sure that the device doesn't get into throttling. And the other thing, if we get close to throttling, we also decrease the frame rate for a couple of frames to make sure the CPU and GPU have enough energy to actually do every work it needs to be doing. And without the Adaptive Performance SDK and the Game SDK, this is not possible because we don't know anything about the thermal status of the device. But now we can. So this is the theory. Did it work? Yes. It essentially worked. In red, we see the same state without Adaptive Performance SDK. And the blue line now is with Adaptive Performance SDK integrated into the game. So what we see is that we are stable at the beginning, stable at 30 FPS for a much, much longer time. And even after arriving in the most busy part of our demo, we still maintain the 30 FPS. And only after we're getting into an even more busy area, we're going to have to drop the frames from 30 to 28 to make sure we're not getting into any thermal throttling state. And by any chance, I came home, tried to integrate like the latest build. I forgot to turn off the device, and it was running over 10 hours and was still maintaining 28 FPS after that long time. So it actually really works very well. So let's have a very quick look on how this looks like. On the left side, adaptive performance is on the right side, it's off. In the beginning, they are very similar. Similar LOD popping, similar similar cars, amount of cars. And then after a while, we realize, well, we get a thermal event. So in adaptive performance, we increase the CPU time. But that means, in this case, we drop the frames for a couple of frames. Because the CPU needs to power up. But at that point, we reach a good, stable 30 FPS again, while without Adaptive Performance SDK, in the next scenario, they actually, like in this case, it actually goes very, very low, like 22 FPS. While in Adaptive Performance, we still fluctuate around the 28 FPS. And this is an overall, in Adaptive Performance state, we can maintain and go up to 28 FPS again. While without FPS, we somewhere are around 20 FPS, which doesn't recover anymore. Of course, you're going to see there are a little bit less cars in the scene with Adaptive Performance because we react on that. They have a lot of vertices, so we remove them or remove some of them. And there is a little bit more LOD popping. But because Megacity is a very dense city and usually we are riding more between houses, it doesn't even affect us so much because there are so many details. Overall, that means though that you have all the control you want to have to make sure that your application actually performs very well over time and way longer, which kind of makes it very nice to tweak your game because usually you know best what you need to improve, what you can decrease and what not. So we want to give you the tools to make sure you can change the LOD bias. That might not make sense in your game, but it might. You might want to reduce the particle effects to reduce overdraw if you're GPU bound, things like that. So we don't really care what you do because it's your decision. You know the game best. So to make that possible in Unity, it's rather easy. So we're gonna release a package, and with the Unity Package Manager, it's a one-click installation, which looks like this. There is the Adaptive Performance Preview package, and then you just install it, and that's it. What is happening in the background is, if you build to a capable device like the Samsung Galaxy S10, we start up a management instance, which just prints the status to the console. That's pretty much it. There is not much to do for you more than that, if you decide so. So the thing is, we ship with all the source code. So if you don't like what we offer you, you can just skip all that or modify it or whatever you want to do if you think it's a better solution. But if you decide to use the Adaptive Performance Manager, it's super easy to just implement it because you have your script, you add your script, you check for the Adaptive Performance Manager instance, and then you subscribe to the thermal events, to bottleneck events. And in this case, this is like for Megacity in the main menu, we set the CPU level and the GPU level to the lowest level because there is not much happening in the menu and we want to keep energy preserved. So how it works within Megacity is that we subscribe to thermal status changes, and those are, for example, the throttling imminent event or the throttling state. So what we do is, if we are all fine, we just go 30 FPS straight line. If we receive throttling imminent events, this means the device is getting hot. We need to make sure we're not going into throttling. We lower the target FPS to 28. While if there is throttling happening, which in Megacity right now it does not, we simply would set it to 15 FPS. While during profiling, we actually found out that in this case, it would make sense to put it to 20 FPS because it's even more sustainable, and the throttling state itself is way better already than actually we could do at 15 FPS within the game. But it also shows that you can really decide what you want to do. And then there are also the performance bottleneck events. And those events basically are either tell you if you're GPU bound, if you're CPU bound, and if you're target frame rate bound. So in case if you're GPU or CPU bound, what we do is we basically say, well, we're going to raise the CPU or GPU level respectively because you need more energy or you need more more power on the CPU or GPU. If this is not possible anymore, or for some other reasons, we lower the LODs. This is a very simple example, so you can do whatever you want to do in this case. And in case of the target frame rate bound situation, that means, well, you reach a target frame rate there isn't that much to do. CPU is fine, GPU is fine. So maybe we can reduce the CPU level, the GPU level, or erase the details of the scene again, which we do with like the raise LOD again. Yeah, so you might see that it's really fairly simple to integrate that in any Unity game. And basically, the thing is that we will release the adaptive performance preview in the upcoming weeks. And we are more than happy for you to get it, to try it, to see how it performs. Give us feedback. We are more than happy to receive feedback if our manager makes sense or if it doesn't make sense. We really like to hear all kinds of use cases. But this is basically only to kick things off. So we work closely with Samsung the last couple of months to actually make that possible. And we give them, I think, very valuable feedback for the GameSDK, while they provide us with all the technical details for their Samsung devices to actually get things done properly. And right now, we are targeting the reference device, the S10, but we also have plans to support the Galaxy Fold and also go into like following in the upcoming months to also broaden that into the Galaxy, Samsung Galaxy family of devices. So that means it goes also into the hands of like many users have those devices. So if you have a game running on those devices, you're gonna have a very good impact. So what does this mean in general? The preview works with Unity 2019.1, and we're gonna go like from the preview package into the verifying state with Unity 2019.3. But this basically is not that we are done at that point. It's basically the opposite. It gives us the opportunity to even ramp up support and development of even more features. And especially in cooperation with Samsung to figure out like what might make even more sense and what do we have to add to the devices. And we also want to see like the game adaptive performance manager is like a high-level component, while there is also the low-level component. And the low-level component is something which is, a very low-level API. While the high-level component, we want to add more and more and more so that like designers don't even have to bother with any of the code. They just can add like a particle LOD component onto their particle system, set which of the particle things should be adapted, and then they can just use it and it scales automatically. So those ideas we wanna push in future and make possible. So yeah, I think that's it for now. We got a couple of minutes left for some questions, but I also will be on the Unity booth 2 to 7 all week. There is also my email address if you want to reach me directly, or the GameDevs at Samsung. And yeah, thank you so much. And I think we're gonna, maybe there are some questions. If there are questions, we can answer those. Any questions?
Okay, people is waiting for this. Thank you so much for joining this session. So it's really exciting. We are working with Unity to deliver adaptive performance, and also we improving the game SDK feature set and also the quality of more precise information about the device can deliver to the game application or game engine. So for honorably say, you guys have already the ticket. Can you show me your ticket? So we're gonna give you the one of you that the Galaxy S10 Plus. This is Verizon model. Sorry about that, but anyway. Yeah. So, okay, how I can open this? Cool. So the Galaxy S10 Plus go to, wow. Who is number 100? 100.
Nice.
Cool.
Yeah.